Hello everyone, this is the third video of our playlist of learning Python from basics to the advanced level. I am Shriya Keshri and I will be helping you to understand all this concept in these videos. This is the third video and in this video we will be covering all the operators and the number system. We will be learning logical, membership and identity operators, and we also are going to learn binary, octal and decimal numbers. In the previous video, we have covered about the data types. We learned the fundamental data types that were int, float, string, boolean. We also learned about type conversion. That is how we convert one data type to the other. We used int, string, float functions to do this type conversion. Then we learned how we can take users input and how we can print our messages on the console. Then we learned about the arithmetic operators and the assignment operators as well. In this video, we are going to cover the logical operators, that is AND, OR, and NOT, and we will be also learning the syntax. Then we have the membership operators. In this, we are going to learn in and not in. Then there is identity operator, that is, and we are also going to understand the value equality here. Then we will learn about the number system essentials. We will be only learning those number system essentials that we are going to need in this course. That is binary, octal, hexadecimal, and decimal based representation. And then we will do some practice question. So let's start with the first topic. The first one is, what are operators? So operators are special symbols in Python that execute a specific mathematical, relational, or logical computation on operands that may be variable and literal values. So what are operators? Basically, whenever we use some special kind of symbol along with our variable and the values that may perform some specific function that may be mathematical or relational or logical, then those special symbols are called operators. In the previous video, we have learned about the arithmetic operators and the assignment operator. Arithmetic operator performed mathematical operations between variable and literal. And then we had assignment operator that assigned the value to the variable. So these are the special symbols which are used along with variables and literals to do some specific function, right? Here in this video, we are going to cover logical operators that combine Boolean sub-expression. Then we will be covering membership operators, which is used for searching elements in the containers. Then we have identity operator, where we use it to verify the memory object references. Okay, so let us come to the first topic, that is the logical operator. Okay, yeah. So we have three logical operators, and these logical operators always evaluate to either true or false, i.e. when we use them, they always give us the answer in Boolean. Either it will be true or it will be false. So the first one is the AND operator. We also call it logical AND, and it returns true only if both the conditions evaluate to true. So let us imagine that there are two conditions. If both of them are true, then only AND will return true. For example, if I'm saying that I am sitting here and I am talking to you, then the first condition is true, that yes, I am sitting right here, I'm not standing. And the second one is true as well, because I am talking right now. So both of the condition is true. That means AND will return true here. Then the second operator here is OR, that is also called logical OR. It returns true if at least one condition evaluates to true. That means it doesn't need both of the condition to be true. If only one of the condition is true, then OR will return true. For example, if I say that I am standing and I am talking to you, then I am not standing, so this is false. But I am talking to you, that means it's true. So from these two conditions, the latter one is true, right? So even if one of the condition is true, OR will return true here. And the last one of the logical operator is logical NOT. So its function is basically to reverse the Boolean evaluation state. So it will reverse whatever answer we are getting. So if we are getting true, it will return false, and if we are getting false, then it will return true. Okay. So the first one we are going to cover is the AND operator. So here is a truth table that says there are two conditions A and B. So if A is true and B is true, then A and B will be true. If both of the condition is true, then the result will be true as well. But in the second condition, we have A is true, but B is false. So one of them is false, then A and B will return false. Similarly, if A is false and B is true, the answer will be false as well. And if both of them are false, then the answer will be false as well. So A and B will return true if and only if both of the condition is true. For example, we have an example here that says age is 20. So it says that the result is equal to age is greater than 18 and age should be less than 25. Then we have to print the result. So what does this code says? The code says that age is 20 and there is a result variable that stores the value here which says age is greater than 18 and age is less than 25. So here both of the condition is true, right? Age is 20 that is greater than 18 and age is 20 that is smaller than 25. So both of the condition is true here. That means if A and B are true here, then A and B will return true. So here the result variable will store true. So when we will print result, the output will be true. Yes. The next one is the OR operator. The truth table here is if A and B are true, then it will return true. If A is true and B is false, then it will return true only. If A is false and B is true, then it will return true. If both of them are false, then A or B will be false. So what does it mean? It means that either of the condition is true, then it will return true. And if both of the condition is true, then well and good, it will return true only. For example, we are saying that marks is equal to 45, right? So now we are storing the result that marks should be greater than 90 or marks should be less than 50. So if we check the first condition, it says marks should be greater than 90, which is false. This condition is false. Then we'll check the next condition, that is marks is less than 50. So here it will say that the second condition is true because marks 45 is less than 50. So since this condition is true, then it will evaluate to true. So when we will print result, it will say true only. This is all about the OR operator. Then is the NOT operator. NOT operator, as I told you before as well, NOT operators basically reverse the answer that we are getting. If we are getting true, then it will show say false. If we are getting false, then it will show true. For example, here is logged in is false, and if I say print not is logged in, then false will be reversed and it will evaluate to true. Similarly, in this example, we are saying print not true, right? Then what will it print? It will print false because true is getting reversed here by the not operator, and it will print false only. Now here is an example. X is equal to 15. So now we have an example here. X is equal to 15. Here we are initializing a variable x and we are giving the value 15 here, right? So the first case that we are taking is the AND condition. So we are saying that we have to print x is greater than 10 and x would be less than 20, right? So what will AND condition do here? It will check if both of the condition are true or not. So it will check if 15 is greater than 10, so it will get true. For the second condition, it will check 15 is less than 20. Yes, it is true as well. So when both of the condition is true, and will be evaluated to true as well. So when we print it, we will get the answer true. In the second case, we have the OR condition. So it will also check if x is greater than 20 or x is equal to 15, right? So the first condition will be false because 15 is less than 20, it's not greater than so the first condition is false, right? But if we are going to check the second condition, we have x is equal to 15, right? So yeah, 15, we have the value of x 15 only, so this condition is true. So even if one of the condition is false, or will evaluate to true because one condition is true here as well. In the last case, we have print not x is equal to 15. So we know that x is equal to 15. So this condition will evaluate to true. But since we are using not here, so it will reverse the answer, and reverse of true is false. So it will be printing false. So in the output section, we are getting this false. Okay. Now, before we get to this point, let us do some examples here. Okay. Yeah. Let us consider marks. Yeah. My marks is 94. Okay. Let us consider. Now, I am making a variable here that says when will I pass an exam. And let us take hypothetically that the criteria is marks should be greater than 60, and the upper bound here is marks is less than 100. Okay. So what will happen here when I print this variable? What will happen in this case? So it has the AND condition here. We have the AND operator, right? So it will first check if marks is greater than 60 or not. So yes, marks is 94. It is greater than 60. So this condition will be true. And marks is less than 100. So yes, 94 is less than 100 only. So both of the condition are true here. Hence, AND will return true. So when I will print pass exam, this variable will print true here. Yes, the output is true. But what will happen if I change it to, yeah, let me change the condition. What will happen now? Here, marks is greater than 60. This condition is true. But now, marks is not greater than 100, right? This condition is not true. So, what will AND do here? It has to check that both conditions are true, right? But here, this condition is not true. So, it will return false now. Yes, it is returning false. So, the basic thing that we have to remember is AND will return true if and only if both of the conditions are true. Now, what if I use a different operator here? Yeah. Now I am using the OR operators. Okay. So what will it check? It checks both of the condition. Even if one of them is correct, then it will return true. Right now, both of the condition is true. Marks is greater than 60, marks is less than 100. So both of the condition is true. So it will return true as only. Just like how AND was working. But now, what if I change this? Now I'm saying that mark should be greater than 100. Now also it is returning true. Why? Because this condition is true. Marks is greater than 60. Even if marks is not greater than 100, one of the condition is true. So it will be returning true only. What if I change this? It will return false. Why? Because both of the conditions are false now. It needs at least one of the condition to be true, then only it can give true. But now both of the condition is false, so the answer is evaluated to false. Right. Now what if I use not operator here? So as we have studied just now, that not operator basically reverses the answer we are getting. So earlier we were getting false. So now that I'm using not, what should I get? True. Why? Because the reverse of false is true. What if I change certain things? Yeah. Now this condition is true, so OR will give the answer as true. So now this pass exam is storing true. So when I will do this not, now it should return false. Yes, this is how it is working. So far we have learned how to use AND, OR and NOT operator. Yes. Now there is this one important thing, that is the short circuit evaluation. Let us consider this example. Okay. Okay, so what do we have here? In this concept, we have to understand that whenever this operator is executing itself, it doesn't check the whole condition. Okay, what does it do? It will first check the first condition. It checks marks is greater than 60, right? 94 is greater than 60, yes. So this condition is true. Now, if even if this condition is true or not, whatever their this condition is, it doesn't matter. Why? Because the first condition is true. If this condition is true, then the answer will be true. If this condition is false, then the answer will be true as well. So the result of this condition doesn't affect our result, right? It will return true just because the first condition is true. So it will check this condition if and only if this one is false, right? This is short circuiting. This is what we need to understand here. What if I use a and here? Here, what will and do? And will first check if marks is greater than 60. It will get true, yes. Then it will check the other condition. But what if it gets false here? Yes, if it gets false in the first condition only, it will and it if it gets false in the first condition only, then and will know that yeah, whatever the evaluation of the other condition will be, and will only return false, because it doesn't matter whatever the result of this condition is. Since the first one is false, and will also only return false. Yes, so it won't be checking any condition afterwards. It will only check the first condition, and if it returns false, then it will stop. Yes, it will check other conditions only if the first one is true. This is what short circuiting is, right? So, for example, we see this. It says false and print hello. So, and will first check this condition. It says false. So, we know that from the truth table, if we get false in either of the condition, the result will be false only. It is predefined, yes. So, it won't even check this part. It will only check this, and since it gets false here, so it won't be checking this print hello. It won't be running this thing, and it will just evaluate. So the answer will be false. So when we will run it, no, this hello will not be printed. Why? Because and doesn't even get to here. When it gets false from here, then it will stop here, and it won't be. Python will not print this hello, right? This is what we have here. So if there is false and anything, then we have false. We will only get false as the answer. So we won't be checking this part. We will check this only, and we will stop here. Similarly, if we have true and or, then there is no need to check anything, right? If we have true, we know that the answer is true, the answer is fixed only. So we are just going to skip this part. This anything is going to be skipped. This is what the theory says. Okay. Yeah. So this is a few questions. There are just few questions we need to solve. Okay, let us solve here. Yeah. So the first question is print true and false, right? So what will it check? We have the and operator here. So we know that we need a true in the both of the condition. Yes. From the first condition it's getting true, but from the second condition it's getting false. So we know that if we are going to have false in either of the condition, and will result to be false. So now if I run it, it returns false. Yes. The second question here is to print false and true, right? No, false or true. Now what will we do? What will it do now? We have OR operator. So we know that even if one of the condition is true, it will be evaluated to true. The first one is false. So we will be checking the other one. Here we get true. Since one of the condition is true, the answer will be true as well. So we are getting true, right? Next we have to print not false. Yeah, this is the question, yes. Yeah. So what will happen here? False when reverse is true. So not basically reverses whatever answer we are getting. So when it will return reverse of false, we will get true. So yes, we are getting true. So what answer we are getting? False, true, true. So the answer is false, true, true. Yes, this is it. So this was all about the logical operator. So what we have learned so far in the first topic is that and or not are three logical operator, and returns true if and only if both conditions are true, or will return true if at least one of the condition evaluates to true, and not will return true if the answer is false, and it will return false if the answer is true. So that means it reverses the Boolean evaluation state. Okay, now let's get to the next topic, that is the membership operator. What is membership operator? As we know from the name, we can know from the name itself that it uses membership. Yes. So membership operators are used to test whether a value or a variable is present inside a sequence, such as string, list, tuple, or dictionaries. Yes. So whenever there is a collection such as string, list, tuple, we have learned about these data types in the earlier video. So whenever there is a collection and we want to check if there is a value inside that collection, then we check this using the membership operator. So for example, let us consider this. This is my classes. Yes, these classes are inside this house. Yeah. So this is the part of this house. So if I want to check if this glass is in the house, then I'm going to use this membership operator. We have to just check if a value or a variable is present inside a sequence, inside a collection or not. There are two membership operators. The first one is in, and the next one is the not in. In returns true if element is found in the sequence, and not in returns true if element is not found in the sequence. Okay, now here is an example. We are using the membership in the strings. We have already learned that strings are basically characters which are enclosed by this double quotes. Yes. So we are taking this string Python and we are storing this in the variable name. Okay. So now we are checking if this P character is in the name. So it will check if this capital P is present in the word here. It will check in the string if there is this value here, and by using this in operator, it returns if it is present or not. So yes, P is present here. So it will find that the letter is here and it will return true. Why? Because the uppercase character exists inside Python. Similarly, we are checking print Java in name. So, is Java present in the string Python? So, no, Java can't be found here in Python. So, it is returning false. Why? Because the substring sequence Java does not exist in Python. So, either we can check a single character such as P here, or we can check a substring such as Java in a string using this membership operator. We could also use not in. What if we had this print Java not in Python? What would happen then? Then it will check if Java is not present in Python. So yes, Java is not present in Python, then it would evaluate to true. Yes. Okay. Similarly, we have our list here. Let us consider this. Marks, we have a list named marks, and in the list we are storing three values, 50, 60, and 70. Now we are checking if 60 is present in this list, right? So what will we read? We write print to 60 in marks. So it will check if 60 value is there in our list. So it will check in the first position, the second position, and yes, it will get that this value is present here. So it will return true. Similarly, in the second condition, we have print 80 not in marks. So it will check if 80 is there or not. So it will get yes, 80 is not in there. So this not in expression will result in true as well. So both of the condition will be resulting to true. Yes. Similarly, we have dictionaries, but since dictionaries are basically key and value pair, we can use membership operator only on the keys, not on the values. If we try to find Rahul and 20, we can't approach that because these are the values. We can use membership operators only on the keys. So if I write print name in student, it will check if there is a key here, named name. So yes, it will find here name. If we print Rahul in student, then it will also check if there is a key named Rahul, but there is no key here. Rahul is a not a key, right? So it will write false. Here is a practice question for the same. Yeah. So there is a practice question here. It says we have a list named colors and we are storing red, green, and blue in this. Okay. So we are basically making a list and we are storing string values inside that list. Now we first check that if red string is present in this list colors, yes. So it will check if there is a value inside the list which is named red. And since R here is capital, and this is case sensitive, so small r red and capital R red will be considered different, and then how it is returning us false. Okay. Similarly, we have print yellow not in colors. So yes, it will check if there is color here or not, and we are evaluating it to not. There is no yellow in the colors. So yellow not in colors will return true. Similarly, we have print pi in Python. So pi in Python, yeah. So here pi has p in the lower case, but in Python p is in the upper case, right? Yeah. So it will return false. So what we have to be careful about is that the lower case and the upper case are considered different, i.e. this is a case sensitive topic. Okay. Now let us practice some. Let us see. So I have an operator. I am considering a variable a and I am assigning it a value. Python programming. Since this is a word, it is a collection of characters and it is being stored inside a double quotes, we know that this is a string. Now I want to find if program this program substring in A. What do you think it will return? So here, if I run it, it will return false. Why is that? Because here in program that I have written, the P is small, but here the P is capital. So since it is case sensitive, it is going to return false. Now if I change it to capital P and I will do it again, then it will return true. Why now? Because program is part of this word programming, so it is part of A as well. Similarly, if I print ing not in A, what will it say? It say false. Why? Because ing is inside A. So by not in, we are going to get false. Similarly, if I write Shriya in A, it will give false because there is no substring named Shriya in Python programming. So this is how it works. This is how we use in and not in when we have to do it on the strings. Now what if I do marks? So there is a variable named age and I am going to store some of the ages of people here. Yes, these are the ages. I do not want this here. These are the ages. Now, if I want to check if there is a person with age 19 in age, then what will it say? It is saying false. Why? Because there is no value that is equal to 19. Similarly, if I check it for 18 in age, what will it return now? It is returning true. Why? Because the first value 18 is there. Similarly, if I do print 34 not in age, what will it return? It will again give false. Why? Because 34 is there, and when I use not, then it will return the reverse of it, that is the false. If I do print 99 not in which, then what will it do? It will write true. So this is how we use operators. We use membership operator in list. Lastly, we have dictionary. So class. So I have a key here, that is trivia, and I'm storing my age with it as value. Then I have Ankit, that is of 25. Then I have Mayank. Mayank of age 14. Then I will have Shikha or 18. Okay. So this is a dictionary. Why? We have a key and a value. So these are the key and value pair we are storing here. Yes, this is the class. Class Python. Because this is the Python class. Yes. So now what if I want to check about the keys? We have already learned that whenever we want to use the membership operator in dictionary, we can't use it on the values. We can only check it for the keys. So if I will write print 19 in class Python, then what will it say? It will say false. Why? Because it is not checking in the values. It will only check the keys. And keys are Shreya, Ankit, Mayank, and Shikha. There is no 19 here. Now, if I will check print Shikha in class Python. Now what will it give? It will now return true. Yes, why? Because it is checking the keys and it is looking out for the keys for with the name Shikha. So here we are finding Shikha. So it will return true. Now what if I say print Rohan in class Python? Then what will it do? It will say false. Why? Because there is no key named Rohan here. Okay. So this is it. Now if I am going to write now what will it return? It will return false. Why? Because Shreya is there here in here. And if I am using not, then they will reverse the answer, that is true, and the reverse of it is false. So this is what happens here. Yes. So far we have considered these examples. Now so this was all about the membership operator. Then we have the identity operator. What we do in this identity operator is that we compare the memory location or the references of two variables to check if they refer to the exact same object in memory. So what does it mean? It means that we are checking that if an object for a variable, it will check if in the memory the object is same in two variables. Okay, this is what we use identity operator is. So identity operator, the first one is and the second one is not. Is returns true if variable points to the identical memory addresses. If in the case of is not will return true if variable point to different memory location. So what does it mean? We have learned about how we assign variable to a value, right? Wherever we allocate a variable, we say that there is a memory location and we are going to store some kind of value in that memory location, and we give the name to that location, that is the variable name, that is the identifier that we have learned. So here now whenever we use the identity operator between two variables, we check if both of the variable points to the same memory location, if the value inside them are pointing out to the same variable storage. Okay, so this is what its purpose is. So we have our equality symbol and the identity symbol. So there is one thing that I want to tell you guys here before we learn any further. If I write this, a is equal to 16, this is the initialization. I am using this a variable and I am giving it the value of 16, and I'm using equal to sign. This equal to sign doesn't compare and the two of them, it only assigns the value to the variable. But if I want to compare the values, if I want to check if the value is true or not, then I have to use this double equal sign. Yes. Then I have to use this double equal to sign. What is the function of this symbol? It checks the value of both of them. A stores 16, B stores 18. This is not equal. So it will return false because they are not equal. So here equal to sign is used for assigning, and double equal to sign is used whenever we have to check the values are equal or not. So we have the equality operator. Its primary function is to check value equality if the values stored in the variables are equal or not. It compares the content of the variable. Okay, and the analogy is two identical passports from different people. Yes, so we are getting two identical passwords from different people. There are two variables and it is storing the same value. This is what equality operator is used for. Then we have the identity operator. Its primary purpose is to check a memory reference identity. So what it does, it doesn't check the value stored inside it. It checks the memory address of it. It checks if the address assigned to the variable is equal or not. For example, let us understand what is the difference between this equality operator and is operator. Here I am saying that a is equal to 16 and b is equal to 18. What if I change the value here? So now when we are checking b is equal to a, then it only checks the value stored inside here. It doesn't check the storage point, it is checking the value. So whenever we have to check the value that is we are storing inside the variable, then we have to use the equality operator. But now when we do not need to check the value, but we are basically checking the storage point, it is checking the place where we are storing. We are checking if both of the variable uses the same place, both of them marks toward the same place where we are storing these values, then we have to check this is. So is basically checks or compares the memory address instead of the value stored in there. The exact same physical passport document is the analogy which we are understanding here. Okay. So now we have an example here that is separate list. Okay, so we are making two lists here. A is equal to 1 and 2, B is equal to 1 and 2. So both of them are list and both of them are both of them are storing the same values here, 1 and 2 only. So now if I write print is equal to B, then it will simply check the values stored inside. It will check, yes, 1 is present in A, 1 is present in B. It will check 2 is present in A, 2 is present in B. And so it will simply return true. It just checks the value and it returns true if the values are equal. But now if I use is operator here, if I check A is B, then this is the identity operator. It will see that both of them, what is the memory ID of both A and B. And then since both of the lists are different, then their memory IDs are different as well. So then it will return false. Why? Because Python creates two separate memory for each of the list A and B. The value might be same, but the memory location is not same. So A is B will return to be false. Yes. Now we have this shared reference. What we are doing here, we are making a list. A is equal to 1 and 2. We are making a list and we are storing value 1 and 2 inside it. And now we are not making another list. We are just referencing the same object here. We are saying B is equal to A. So now we are not making another list. We are not assigning different value, different address to it. We are just making sure that B also points to the same storage place where the values of a is stored. So both b and a now references to the same object. So now if I say print a equals to b using this equality symbol, then it will return true. Why? Because the value is true now as well. But now if I try to print a is b, then it will return true. Why? Because both a and b now references to the same object. Both the object points to the variable a's memory location. There is no new object created, and the contents are identical. Okay, now we have this example visualizing memory reference, that what is happening here. So in the first condition, we are using a is equal to 1 comma 2 and we are writing b is equal to a. Yes. So what is happening here? There is this memory location whose ID is 0x10a and we are storing value 1 and 2. So when I write a is equal to this list of 1 and 2, a is now pointing to this memory. Now if I write b is equal to a, I'm saying that b has to point to the a value. And similarly, the point of b is referencing to the memory allocated in A. So both B and A now share the same reference. They both of them share the same memory location. But in this case, A is allocated a memory where we are storing 1 and 2, and B is being allocated another memory where we are storing 1 and 2. Both of the memory IDs are different. The memory place is different for both of them. So these are two distinct objects, and hence it will return false. This is what is happening in the cases. So this was the last topic of our operator section. This is what we have learned so far in this topic of identity operator. We learned about the identity operator, that was is and is not. We learned about using this equality sign and how they both differ from each other. This is what we have learned so far. Yes. Next, we have introduction to number system. We are going to understand the number system that we use in computing. Yes. So basically, we know that the machine language of a computer uses binary codes 0 and 1. So we need to understand these languages, this number system. We are going to cover the 4 core system in computing, that is decimal, binary, octal, and hexadecimal. So decimal is what we use normally in our mathematics as well. These are the base to 10. Which is a standard human numbering. We have already learned about decimal in our school, in our mathematics classes and all. Then we have this binary, that is base of 2. All the machine native languages use binary codes in this. Then we have the octal, that has the base of 8, and this is compact binary grouping. Then we have hexadecimal, that has base 16. Okay. Yeah. So the first one is the decimal number system. What happens in this? The system properties we have to understand. The first one is the base. We in the decimal number system we take base to be 10. The allowed digits are from 0 to 9. That is 0, 1, 2, 3, 4, 5, 6, 7, and 8 and 9. Yes. So everyday numerical system used globally by human beings is the decimal number system. We have learned about the decimal system. What we do, all the numbers are the base of some powers to 10. Such as here, 582 is positional breakdown. is showing the positional breakdown, how we can write 582 in this format, where we are showing the base to the power, base of the power 10. Yes. Then we have the binary number system. The base is equal to 2 and there are only two allowed digits here, that is 0 and 1. So each number here is either represented using 0 or is represented using 1. So now there is a topic, that is why computer use binary. So computer microprocessor consists of billion microscopic transistors acting as electronic switches. So if high voltage state, then it is considered to be 1, and low voltage state, then it is considered 0. Then we have octal and hexadecimal system. Octal system is the has a base of 8, and the digits which are allowed in here is from 0 to 7. For example, we have here 17.8. This is an example of octal system, and it is used in Unix file permissions such as chmod 755. So these are the commands in Linux. Whenever we will learn Linux and all this, we will understand what this says. Then we have this hexadecimal system, which has the base of 16. There are digits 0 to 9, and we have A to 5, A to F letters. So it both uses digits and it uses A to F. After the number 9, for 10 onwards, we have A to F. A represent 10, B represent 11, C will represent 12, and so on. And lastly, F will represent 15. So this is how we use the hexadecimal system, and it is used for HTML colored codes. So if you remember, whenever we write HTML codes, then whenever we use this color codes, the number we get here in this form for equal to this, then the number that we are using here is none other than the hexadecimal system. And in RAM addresses also is expressed in the hexadecimal system as well. So lastly, yeah, so we need to understand how one number system is converted into two, how binary is converted to decimal, how decimal is converted to binary. So yeah, if we have binary numbers such as 1, 0, 1, 0, what we do here, we multiply it with 2 to the power 0, 1, 2, 3 in the progressive range. So for the digit from the last only, we are starting from 0 and we are multiplying it with the power of that with 2. And when we sum them all together, then we will get the decimal number. Similarly, if we have a decimal number, then we repeatedly divide it by 2 and we choose the remainder we have here and we arrange it in the reverse direction and we will get the binary number that we need. So yeah, this was the last topic. So in this video, what all did we cover? So we first learned about the variable types, that was int, float, string, bools. Then we learned about the input and output operation, how a user can give any input and how we are going to print our output on the console. Then we learned about the arithmetic operators. Then we learned about the assignment operators. And we also learned about the logical operator, that was and, or, and not. Then we learned about the membership operator, that was in and not in. Then we learned identity operators, that is, not, is, and we also learned about the equality operator. And then we learned about the number system, that was of basis to 2, 8, 10, and 16. And we also learned how we can convert one to another. Yes. So this is all that we are going to cover in this video. Let us do a few questions here. Okay. Yeah. So the first question is print true and false. So we have learned about this true operator. Yes. What does true do? True will return and will return true if and only if both the condition are true. So the first condition is true here, but the second condition is not true. It is false. So and will be returning false. Yes, this is what it returns. So the correct answer is false. Then we have to print 10 floor division 3. What does floor division do? What does this two backslashes means? No, these are the slashes. Yeah. So what does this slash double slash means? So it means that we have to return the quotient that is rounded off. So when I will do this, it returns 3. Yes, 3. Floor division truncates the decimal part. The decimal part is removed and we only get the integer part. Then I have to check if P is present in Python. What will I do now? Print P in Python. So what will happen here? It will check if there is an uppercase P present in the word Python. And it will return true. Why? Because there is a capital letter P. Yes, it is returning true. But if there was this small p instead of the uppercase P, then it would return false. Why? Because this is case sensitive. Both the capital P and small p is considered different. Now we have A is a list consisting of 1, 2, then B is a list with same values, and we have to check if A and B point to the same memory location or not. So A is a list which has 1 and 2 value, B is another list which has 1 and 2 value. So here, since the values are same, so if we were to try this, then it will return true. Why? Because the value are same. 1 is here, 1 is here also. 2 is here, 2 is here also, so it will return true. But if I use print A is B, then it will return false. Why? Because is operator doesn't check the values stored, but it checks the memory location to which the variable points. So A points to another memory location, B points to another memory location, so they are not the same, hence it returns false. The last question says convert this is a binary number, so we have to convert this binary number to decimal point. Okay, yes. So what is the binary number? 101101. So yeah, this is the binary number that we have here. Let me comment this out because we do not want to run this part. Yes. So yeah. So this is a binary number and we have to convert this into decimal number. Yes, this is what the question asked. Yes. So how do we do it? How we convert a binary number to the decimal number? So I told you for this we have to just multiply it with 2. Yes, that is what we do. We multiply it with 2, but we put some power to it. Yes. And how will we know what power we are going to use here? Yeah. So what is the power I am going to use here? We count from here 0, 1, 2, 3, 4, 5. So I am going to get this 5. Similarly, this was for the first digit. Yes, I will use the same thing for each of the digits. How many digits are there? Yeah. So the next digit we have 0. And it is in the 4th position, so I use 4. Then we have 1 and it is in the 3rd position. Again, there is a 1 on the 2nd position. And then there is a 0. 0, 1, 1, 0. 5, 4, 3, 2, 1. Yeah. To the power 1. And lastly, I have this. 101101. Yeah. So this was the number and I multiply it with 2 and I put a power to it according to the place where this digit is present. So for 1 I have 0, for 0 I have 1, for 1 I have 2, for this one I have 3, for 0 I have 4 and for 1 I have 5. So when I will calculate this all, we will get what we are going to get. 2 to the power 5 we have 32. Yeah, we have 32. For this we will get 0 only. Yeah, for here we will get 8. 8 for this we will get 4 and this will be 0 only, and lastly for this we will get 1. So what is the answer that we are going to get? 32 plus 8, 40, 45. So the number in the decimal number is 45. So this is the number, the correct answer is 45. So this is the binary number which was this, and we converted it into the decimal, and what we get is it was equal to 45. So this is the third answer. So this was the practice question for unit 1. And these are the sum of the homework assignment that I'm giving. So you can practice whatever we have learned so far using these questions here. So yeah, so this is what we are going to cover in this video. We are going to stop here. In the next video, we will be starting unit 2, which is the unit for which we will learn decision making. We are going to learn if statement, if else, if else, and match cases. This is how we control the program flow. So this is what we will learn in the next class. Yep. So this is it. So yeah, this is it. This is what we have learned so far. So let us meet in the next video.